Hello everyone, welcome back to another video. Today we will be recreating Outhold's node tree system in Unity. The node tree refers to what I would think as like the upgrade tree, or a progression system you see between runs. It's not a physical map you defend on the battlefield, but instead a strategic web of upgrades that you unlock to make future runs stronger. This is a little bit of a disclaimer, but I actually haven't played the game before, so this is just how I see it or refer to it. So I eventually started out with a blank scene and then added a few options into it. I added a global volume, which is all purely for visual, just to make things look a bit fancier. And then an orthographic camera, a background with a -5 order layer, and a simple square which will later be our node. Heading into our code, I first created a script called camera controller 2D, and I added a few variables for the camera, position, and zoom. Then in the awake function, I would initialize these variables. Then for panning, I'll add a few variables, and in a function, I'll record the target position. When clicked, we set the last mouse position to our current world position, then update the current position while dragging, also taking account for pan speed. For zooming, I add a few more variables, then in another function, test to see if we pass our scroll threshold. If so, we set our target zoom and update our position, which we will handle next. I add a few more variables for the bounds, specifically for where the camera will not be able to pass. Then, I do some math to find the bounds and clamp the position to it. Next, I create a function called smooth move, and inside this function, I pass in all of our variables into a smooth dam function. And for the smooth zoom function, I do the same, setting the camera's orthographic size because we're in 2D. Then I call all the handle functions inside of update and all the smooth functions inside of late update. And so that we can visualize our bounding box on draw gizmo selected, we do the same. Back in Unity, I'm going to select our camera and add our script. You can tweak any of the values to be whichever one matches your scene and your project the best. I will adjust mine now. As you can see, I can now move my camera around. It is a bit hard to tell because the only thing I've seen is the little square in the middle, but as you can see in the top right, I am able to move it around. Next, we will work on the lines that connect each of the nodes. I'm going to create a class called SpriteLine2D and initialize some values like the start object and end object and line appearance. Next, in a function called updateLine, we'll take the start position and end position for our objects, then determine the distance and set the position of the line to the midpoint, then handle rotation, scale, and color. Lastly, in our update function, we null check to make sure both the start and end objects are clear, and then update our line. I've created two objects and an ordinary 2D shape to act as our line. I'll then add our 2D line class and then set both the objects as the start object and end object. Next, we will get started on our nodes. I'll create a class called NodeState, which will handle all the different states we can have. Then another class called NodeVisualProfile, which holds all the information about each profile. I created a few assets that I will be using to make these, and got these icons for free off of Unity's asset store. I then tried my best to recreate the nodes that I see in-game with interchangeable parts that I will be able to change using the node profiles in the future. All project files and assets will be found in the description below. I create a new class called the node class, which will have all the properties about our node. I then create a function called apply visuals, which applies all of the data from our visual profiles to all the objects in our node. Then lastly, I will call apply visuals in awake, update, and set states. As you can see, when I change the state in the node class, it updates its visuals to match the profile accordingly. We'll continue on with this functionality by making a spawn direction class holding an angle and weight variable. Then back in our node class, we'll have a few lists, one for connected nodes, spawn directions, and used angles. Then I create a new class called node graph manager, which holds an instance, few variables, and sets its own self as an instance on awake. Then I'll add a void for registering a node. Back in our node class, I added a few helper functions for getting a line color and getting a line, and a few more for seeing if an angle is used and normalizing our angle so it's easier to reference. Then I create a few more functions for connecting nodes and updating line colors, which other scripts can use. I then updated our apply visuals function so that if a node is disabled, it always uses the exact same icon, or whichever icon you set for it. Otherwise, it uses a randomized one from the node graph manager. I then added each of the angles and weights to the node, and these are the angles that other nodes can branch off into whenever it spawns. I then also added a bunch of randomized icons from the asset pack we talked about earlier, and set the settings for the spawn direction and all of that stuff. Now the direction did end up being more than I needed, so I did shrink that. I created a simple prefab, which is just our other script that we had before, except as a prefab so that it can be spawned in between nodes. I will then create a few helper functions, one for making sure or checking if a position is free, another to connect nodes together. Then an expand node function, which takes in a node and how many output nodes we want, and based on the candidates we'll pick which ones to spawn where if the position is free. Then in our node class, I'll add a function for leveling up, and based on some conditions we'll determine how to level up and which nodes to use. And to be able to get our input, a simple on-mouse function will capture it and level up. Then I update our awake, updates, and set state to account for these new features. Now, if you click on a node, if it's disabled, it will branch off into another node, and you're able to upgrade already existing blue nodes. You're not able to upgrade a blue node to a golden node unless all of the surrounding ones are also blue. Just a little functionality which is not like the game, but it is just an example of how you can use states and scripts to be able to make something like this. I know that was a lot. If you have any questions, you can go ahead and ask me. Join the Discord down below. Thank you for watching. All the projects and the assets will be in the description below. Thank you. Have a good day.